Okay, let's start. Okay, hi guys. In this video, I'm going to cover the syllabus for the gate architecture. Uh, I'm going to cover the main topics will be first one will be landscape, then the numericals and theory based on light, sounds numerical, heat and ventilation numericals, numerical based on construction management and transportation, and the structure, and little bit of math aptitude like APGP and numericals of log and integration and the graph, and the main history and town planning. According to me, the structure is the scoring. Okay, let's start with golden ratio. Golden ratio is just basically the division of two sides, that is A by B. It is the ratio which should be equal to 1 is to 1.618. Okay, let's take an example. If it's A, if it's B, and it's A plus B. According to golden ratio, if we divide A plus B upon A, it should be equal to A by B. It is given that A is greater than B and is also greater than 0. Okay, let's derive for this value. We will give its constant alpha. Now A upon A, B upon A upon B, 1 plus 1 upon alpha alpha 1 alpha square minus 1 0. Remembering the formula, minus b plus minus under root b square minus 4ac upon 2a plus 1 plus minus b square minus 4 ac upon 2a 1 plus minus 5 upon 2 and नेगेटिव ऑफ अंडर रूट, तो नेगेटिव वैल्यू हो नहीं सकती, तो द रिजल्ट विल बी 1 प्लस रूट 5 अपॉन 2 and it come to be 1.618. ओके, ना गोल्डन रेशियो काम आती है हमारे, अगर आप देखें लियोनार्डो दा विंची, उन्होंने जो पोर्ट्रेट बनाया था मोनालिसा का, वो भी एक गोल्डन रेशियो में था. इट इज सेड दैट कि आपका हाथ इज आल्सो इन द गोल्डन रेशियो. लाइक एक स्क्वायर है ए, एक स्क्वायर का भी गोल्डन रेशियो में नहीं हो सकता, बट एक रेक्टेंगल को गोल्डन रेशियो तब कहा जाएगा जब उसमें हम b इतना ऐड कर दें सच दैट a प्लस बी अपॉन ए इक्वल टू a अपॉन b, दैट इज a प्लस b. Okay, coming to the landscape part. लैंडस्केप में बेसिकली एक न्यूमेरिकल आता है एंड एक थ्योरी। थ्योरी में बेसिकली मेनली बोटनिकल नेम्स आते हैं एंड टाइप्स ऑफ गार्डन्स। टाइप्स ऑफ गार्डन लाइक जापानीज गार्डन, मुगल गार्डन, इजिप्शियन गार्डन, ये सब कुछ गार्डन्स। बट आई विल कवर ओनली botanical names in the landscape theory part. In the numericals basically कंटूर बेस आते हैं एंड आते हैं स्लोप एंड ग्रेडियंट बेस एंड आते हैं रन ऑफ कोफिशिएंट बेस। So let's start with run of coefficient numericals. Run of coefficient. Run of coefficient is the percentage of volume of rain which a surface allow as a storm water. Means एक surface है, उस पे इतना वॉल्यूम पानी गिरा, मीन्स ऑफ कोर्स mm में हाइट में गिरता है पानी, mm या जो भी यूनिट हो, दैट इज द एरिया। बट द सरफेस, एक सरफेस एब्जॉर्ब करता है एंड सम पार्ट एब्जॉर्ब कर लिया एंड रेस्ट पार्ट वो एज ए स्टॉर्म वाटर रन ऑफ कर देता है। तो किसी भी सरफेस का रन ऑफ कोफिशिएंट होता है कि वो कितना पार्ट रन करने देता है। लाइक इस पर 100% पानी गिरा है तो उसमें से ये सिर्फ 90% अलाउ करता है, तो इसका रन ऑफ वो कोफिशिएंट हो गया 0.9। रन ऑफ कोफिशिएंट वेरीज करता है 0 to 1 एंड किसी भी एरिया कितनी वो रन ऑफ कर देगा वाटर को एज अ स्टॉर्म वाटर, वो निकालने के लिए उस सरफेस का एरिया इनटू में हाइट, ये आ गया पूरा वॉल्यूम, एंड इनटू में उसका रन ऑफ कोफिशिएंट, ये आता है वो वॉल्यूम जितना एक सरफेस अलाउ करेगा एज अ स्टॉर्म वाटर, बाकी रेस्ट वो एब्जॉर्व कर लेगा। ओके इसमें बेसिकली आपको यूनिट्स स्ट्रॉन्ग होनी चाहिए, लाइक 1 मीटर क्यूब इज इक्वल टू 1000 लीटर। मीन्स इफ वी मेड अ बॉक्स ऑफ 1 by 1 मीटर तो उसमें आपकी 1000 लीटर वाटर आ सकता है। एंड 1 एकड़ इज इक्वल टू 47 स्क्वायर मीटर एंड 1 हेक्टेयर इक्वल टू 10,000 स्क्वायर मीटर एंड 1 मीटर इज इक्वल टू 3 फुट 3 इंच एंड 1 यार्ड इक्वल टू ओनली 3 फुट यानी कि 36 इंच 39 इंच। ओके इसका एक न्यूमेरिकल करके देख लेते हैं। आई एम टेकिंग द न्यूमेरिकल फ्रॉम गेट 2015 क्वेश्चन नंबर 60। बेसिक न्यूमेरिकल्स आते हैं, डायरेक्ट फॉर्मूला अप्लाइड होता है। इसमें उन्होंने हमारे पास टोटल एरिया दे रखा है साइट का, दैट इज 35,000 स्क्वायर मीटर एंड उन्होंने बता रखा है कि ब्रिक पेविंग हमारे पास है 20%, सीमेंट है हमारे, सीमेंट कंक्रीट 15%, रेस्ट विद ग्रास। ओके तो 100 में से माइनस कर लेते हैं, दैट इज 35 एंड 65%। एंड साथ में उन्होंने हाइट दे रखी है कि रेन हुई है हमारी 70 mm पर आवर। ओके एंड इनके कोफिशिएंट हमारे पास दे रखे हैं 0.8, 0.9, 0.5। सो सिंपल से हम निकाल लेते हैं। सिंपल फॉर्मूला है एरिया इनटू में उसका कोरस्पॉन्डिंग रन ऑफ कोफिशिएंट इनटू में हाइट ओके, तो हम पहले कॉमन ले लेते हैं। ओके, मैं एक्सप्लेन ही कर देता हूँ। 20/100 इंटू में दैट ए इंटू में रन ऑफ कोफिशिएंट इंटू में 70 mm। को हम चेंज कर देते हैं मीटर में, दैट इज 10⁻³ ये एक आया ब्रिक पेविंग का। ऐसे ही सीमेंट का एंड देन ग्रास का। मैं डायरेक्ट इक्वेशन लिख देता हूँ। बाय टेकिंग ए कॉमन 20/100 into 0.8. Okay, HP we can take common, H plus 15% into 0.9 plus 65% into 0.5 A into H, and we can solve this and we will get answer in meter cube per hour. Or if they are in liter, you can convert meter cube into liter per hour, मीन्स इतना लीटर पर आवर हमें रन ऑफ मिलेगा। Now coming to the numericals of slope and contours. स्लोप में बेसिकली हमारे पास थोड़ा सा मैथ का एप्टीट्यूड होना चाहिए, दैट इज अ ट्राइंगल इज सिमिलर if its angle are similar, means if you remember A, triple A, S, and S. These are the properties of similarities. Okay, now basically क्वेश्चन आते सिंपल से हैं कि आपकी साइड स्लोप में है एंड इसका मैं सेक्शन बना देता हूँ। This is the side, this will be theta given and they will ask कि कितना वॉल्यूम उन्हें एक्सकेवेट करना होगा इस साइड को लेवल हॉरिजॉन्टल पे लाने के लिए। सो यू विल सिंपली फाइंड आउट द लेंथ, ब्रेड्थ एंड हाइट एंड यू विल इजीली गिव द वॉल्यूम। ओके, and then the problems which comes contours. As we all are familiar with contours, इसमें हम बेसिकली आपको ट्रिग्नोमेट्री आनी चाहिए जो आपको याद होगी, साइन थीटा, कोस थीटा एंड टेन थीटा। पी एच, बी एच, पी बी। ओके, नाउ कंटूर्स बेसिकली मैं एक बार रिवाइज करा देता हूँ क्या होते हैं। इफ वी मेक दिस इज द एलिवेशन and if we make a plan of this, its plan will be ये, this and this line, this and this line, means सेम हॉरिजॉन्टल लेवल पे जो लाइन होंगी वो मीट करेंगी, दैट इज कंटूर्स। ओके, कंटूर्स में जो मेन प्रॉब्लम होती है वो ये होती है कि लाइन, सॉरी, we have given a line. If we have to divide a line into two parts, that is 1 and 2, we have to divide a line by 2. But in contours they will ask to divide the line in 3 lines, means divide the plot in 3 lines. Assume this is a plot and we have to divide the make a contours of 3 lines. So means just dividing this length by 3 lines, but they will ask for divide the area into 3 contour lines, but we have to divide it by 2. If they will ask for divide the area into 6 lines, means 1 2 1 2 3 4 5 and 6 contour line they will if they ask, but we have to divide the length into 1 2 3 4 5. This will give the contour. Now we have two. One is contour interval and other is contour distance. Contour interval is the division in height. Means if this is a contour we have given, if they will ask for contour interval in plan, if it is like this, they will ask for contour interval. So we have to divide h by 1 2 3 4, not the l by 4. If they will ask for contour distance, then we have to divide l by 4. Otherwise, if they will ask for contour intervals, we have to divide the height. We have to give the distance of this to this. It is known as contour interval. And this is contour distance. Okay. Okay, after contours, scale numericals also come. Scale numericals, दो टाइप के स्केल न्यूमेरिकल्स आते हैं, एक तो लेंथ एंड एरिया बेस एंड एक आते हैं एरियल स्केल. Scale on the length, as we know, if we have given L length on the real side and we draw it on the map with XL, X could be smaller or greater, then the scale is L upon XL is equal to 1:X, means scale is X. But in case of area, this is the case of length. In case of area, means if it is, assume A, it is B, and we draw on the map as scale is same X, so it becomes XB and XA. It could be also greater, that depend upon your scale, XA, XB. But the main point is either area is AB and here area is x square AB, and if we want to find the scale will be under root of AB upon x square AB, so that we get 1 upon x. Because we know the scale is x, in area it unit get doubles, whole square, meter square, so we have to under root the unit to get the scale. Okay, now in the simple aerial scale we have just a formula, aerial scale equal to focal length or focal distance upon the altitude or height from the ground level, not the sea level, or the level on the structure is located. Means if this is the focal length, here is the lens, the height we're going to take from here, this is the land, and sometimes it is given water level, sea level, but we will going to take the height from here. Sometimes confusion questions also come, and they will ask for the point here, and we have to take the height from here. Okay, this is the aerial scale, this is the scale. We can take question from 2015, question number 55. The roof area of building is given 36 square meter, and on the side plan we make it into 25 square centimeter. They ask for scale. Now it's just a simple scale equal to make it into 25 into 10 raised to power minus 2 into 10 raised to power minus 2 meter square, and just divide it and root it. You will get the scale. Actual area upon area on map. This is from the scale. Okay, now coming to the botanical names for the landscape. These are the trees and their botanical names. I'm not going to say you learn these names, because these, as a question comes objective types, I will make you learn here right now. We have to just remember the main words, so that वहाँ पे हमें just वो नाम दिखे and we can easily find out the main. Like we will remember the tree name for the Azad India. Azad India. Mango for the Mangni. These are just simple. आप उसमें ऑप्शंस में इनको देखते ही पहचान जाओगे कि ये किससे अटैच होगा. लाइक पीपल हमारा रिलीजियस होता है, तो रिलीजियस. आपको ये नाम याद करने की जरूरत ही नहीं है, बोटनिकल नेम्स. ओके, बनियान, बेंगल जहाँ भी आए बनियान. गुलमोहर से खुशबू आती है, सो इट्स फॉर डेलो. गुलमोहर डियो से डेलो. टमरिंड का ऑफकोर्स सेम है. जैक फ्रूट, जैक फॉर जैक स्पैरो और पायरेट्स ऑफ कैरेबियन ऑक्टोपस. आर्टोकार, ऑक्टोपस या आप इसको याद रख सकते हैं. क्रैकन, आर्टोकैरपस. जैस्मीन सेम एज जैस्मिनम. मैरीगोल्ड. मैरीगोल्ड की एक खासियत होती है कि वो सूरज को फॉलो करता है, मीन्स टाइम कैलेंडर. सो कैलेंड्यूला, वी विल रिमेंबर द कैलेंड्यूला फॉर मैरीगोल्ड. रोज सेम एज रोज. एमाल्टस फिस्टुला. नाउ अशोका फॉर अशोका और पोलीलोंजी. बासिल बासिल मीन्स तुलसी, तुलसी का एक स्पेशल नाम होता है ओसिमम सैंक्टम, ये आपने जनरली मंदिरों में भी सुना होगा, बासिल ओसिमम सैंक्टम। ओके, कोकोनट, कोकोस, एंड बैम्बू, बैम्बू होता है आपके डंडे, इन हिंदी डंडा, डंडा से याद रखेंगे डेंड्रो, डेंड्रो। ओके, टीक, टीक होता है सुई की तरह, दैट इज ग्रैंडिस, ग्रैंड डिस, ग्रैंड से गैंड दिस। ओके, पलश, पलश इज सच अ, जिसमें सिर्फ एक चीज आएगी, स्पर्मा, स्पर्म, प्लस से उस टाइप की फीलिंग आती है, एंड स्पर्म इज सेम फॉर दैट। ओके, स्पर्मा एंड शीशम, शिशु। You don't have to remember these botanical names because in the gate options will be there, and you can easily, by looking at their your, you can make your own, so that आप वहाँ पे जाके जैसे आपको मैच द फ्लोइंग करने हैं, आप अपने ही कुछ भी बना सकते हैं, उनसे आपको आसानी हो जाएगी। ओके, this is the from the landscape. Now coming to the numericals of lights. लाइट से बेसिकली 3 न्यूमेरिकल्स आते हैं, 3 क्वेश्चन, और बहुत ही आसान होते हैं, ईजिली हो जाते हैं, जस्ट सीधा फॉर्मूला टाइप आते हैं। ओके, एज वी नो लाइट परफॉर्म बोथ एक्टिविटीज, वेव एंड पार्टिकल, और light travel in the form of with a package of photons. If a light is traveling there, then we know that photons, in the form of photons, light traveling, and as we know, if light is traveling, then there is electric field as well as magnetic field. If light is traveling in this direction, then these both are perpendicular to each other. These both these are perpendicular. Okay, and simple, c is equal to 3 to 10 to the power 8 meter per second, and c is equal to lambda into frequency. C is speed of light, we all know, and lambda equal to wavelength, frequency equal to frequency. Okay, and now the visible range. Visible range is, we know, wavelength should be 0.40 centimeter to 0.407 centimeter. This is the visible range of wavelength we can see. Okay, our diagram, like this is a ball and this is our light source, and this is our screen. This is the blackest part from the light shadows, you can imagine, and this is the lighter part. This is known as umbra and this is penumbra. Okay, now coming to the मेन क्वेश्चंस, दैट इज अभी तक हमने जो एंगल पढ़े थे दैट इज 2D एंगल्स, मीन्स if there is a two balls, the angle is 2D angle between two lines, it is formed between two lines. Now we will study 3D angles. 3D angles, that is solid angles or steradians. These are 3D angles. 3D angles like if it is a light source and it is a screen and we have covered this light source with the obstacles, so suppose it is making this part only illuminating, only this part. So to find out this angle, this is 3D angle. The formula for 3D angle is solid angle is equal to area upon r square, means this area into r का distance. R is the distance from the light source to that area. For example, if this is a light source and it is making a spherical, not a circle, a spherical illuminating. So to what is this angle? What will be this angle? The area of sphere, that is 4 pi r square, and distance from the, that is r, the radius of the sphere, that is r square. By solving this, r square cancel out r square and we get 4 pi. We can also write it 4 into 180 or 2 into 360, means this is 360 and this is 360. I'll make it another. This is sphere 2 into 360 degree. 2 into 360 degree. 1 360 is this, and the sphere in the x-axis 1 360 degree is this, as it is a sphere. Okay, we will see for hemisphere. If light source is this and rest part is obstacled by other thing, so the area upon r square is equal to 2 pi r square upon r square. R is the same distance and 2 pi r square is the area of the hemisphere. R square cancel out r square. 2 into pi means 2 into 180 degree, means it is a hemisphere 180 degree and 180 degree. So 2 into 180 degree and 2 into 360 degree. This is the solid angles. Now coming to the light. लाइट में बेसिकली आपको 4 टर्म्स याद रखनी है. फर्स्ट वन इज लुमिनस फ्लक्स, luminous intensity, solid angle we have done, and illumination. Illumination. Okay, now coming to the luminous flux. Luminous flux is basically the total area luminous flux. Luminous flux unit is lumens and we denote it by F. Now luminous intensity. Luminous intensity is the luminous flux to the angle, solid angle. Means luminous intensity we denote by I. Means I is equal to F upon rho. F upon from the previous area upon R square, solid angle area upon R square, that is solid angle area into my R square, flux same into my R square, area is 4 pi R square. Area will be given, but for the flux, luminous flux is the total intensity. Means for the luminous flux, area will be 4 pi R square. We calculate the luminous flux for the whole round surface. Okay, now putting this area into this, I is equal to flux into my R square upon 4 pi R square cancel out R square, and flux will be 4 pi I. So this is the formula for flux and this is the formula for I. I is equal to flux upon rho. Okay, now coming to the illumination, that is denoted by E and its unit is lux. Okay, E is equal to, illumination is the ratio of flux to per unit time, flux per unit area, sorry. E is equal to flux upon area, and we know for the flux is 4 pi I upon area 4 pi R square, so I upon R square. So illumination have two formula, E is equal to flux upon area or E is equal to intensity upon R square. Luminous intensity has unit candela, CD candela. Okay, now I will redefine it. Luminous flux and luminous intensity and illumination. Unit is luminous flux, unit is lumens. Luminous intensity unit is candela and unit of illumination is lux. Formula for luminous flux is 4 pi I. Luminous intensity is flux upon rho. Illumination is flux upon area, or I upon R square. So its unit will be sometimes flux, that is lumens per meter square, or candela per meter square. Okay. Unit of luminous intensity will be lumens per solid angle, or steradians. That is okay. That is luminous flux, luminous intensity, and illumination. Sometimes question comes from these units, so these are important. Now one more thing in the lighting numericals is depreciation factor. Depreciation factor, that is equal to coefficient of utilization into coefficient of maintenance. Depreciation factor can be useful in any type of क्वेश्चंस. मीन्स आपको एक 40 वाट का बल्ब, वी नीड मीन्स हमें नीड है 40 वाट की, एंड उन्होंने क्वेश्चन में देखा कि कोफिशिएंट ऑफ यूटिलाइजेशन, कोफिशिएंट ऑफ मेंटेनेंस भी इस पर लगेगा, एंड वी नीड 40 वाट. सो हाउ मच वाट का बल्ब हमें चाहिए? सो लेट्स सपोज वी नीड x वाट का बल्ब. वी नीड ओनली 40 वाट्स, बट we will take x watt का bulb into coefficient of utilization. We can take it, let's suppose it's 0.8, and coefficient of maintenance be 0.5. Now x will be 40 upon 0.8 into 0.5 watt, x equal to watt. Depreciation factor. Depreciation factor is divided by we need the how much. Okay. One more thing in the light is inverse square law. Inverse square. Okay, we are talking about inverse square law. If E is the illumination, I is the luminous intensity, and E is the illumination, then we know that E is equal to I upon R square, means E is directly proportional to R square. If R is the distance and E is the illumination here, then after 2R distance, means again R, E will be 1 upon 2R square, that is 1 upon 4 R square, means E will be 1 by 4th of original E, here wala E. So that is inverse square law. With increasing the distance, with the intensity of illumination also decrease. Okay. Now one more thing in lighting numericals is daylight factor. Daylight factor, that is equal to illumination of inside upon illumination of outside into 100%. Okay, and one more formula for this is D is equal to 0.1 into P. Now P here is the percentage of glazing area to the floor area. Now glazing. Now let's have an example. This is a room and this is a window, and from this the glazing area is, we assume here is this only glazing area to the, this is the glazing area and this is the whole area. This is daylight factor. Okay, and that's it from the form. That's all from the light. Now coming to the numericals for the sound. साउंड बेसिकली मेन न्यूमेरिकल आता है रिवर्बरेशन टाइम का, रिवर्बरेशन टाइम, एंड सेकंड जो न्यूमेरिकल आता है वो सेम से होते हैं, प्रेशर लेवल और इंटेंसिटी लेवल. वाओ दीस डॉग्स आर गली के कुत्ते. ओके, नाउ द रिवर्बरेशन टाइम. Reverberation time, as we all know, reverberation time is the time taken by the sound to, reverberation time is the time taken by the sound so that इसकी intensity 60 decibel हो जाए, because after the 60 decibel we can't hear, so that is the reverberation time. Now there is a simple formula for reverberation time. T is equal to 0.16 into volume of room upon area or absorption means, for example, if we have this room, means L, B and H. Suppose here is the same thing, that thing that matter, area into coefficient of absorption for sound, that is converted to Sabines, that is the unit of absorption. Now let's suppose this wall has coefficient of absorption 0.1, and you can take any other wall as 0.2 and so on. So B into H, area, has coefficient 0.1 plus same the H and the B into H has 0.2 plus so on. You will get the area of absorption, and volume of room is same, LB into H, so the reverberation time will be 0.6 into LB into H upon this whole area of absorption, multiply with their respectively coefficient of absorption, area into corresponding absorption summation. Okay, now the second thing which come into sound intensity level. Sound intensity level. The formula for this, we have only a simple formula, 10 log 10 I upon I naught decibel, and here comes a sound pressure level, that is 20 log 10 P upon P naught decibel. Here I is the intensity of sound we are measuring, जिसके लिए हम निकाल रहे हैं प्रेशर. and here P is the pressure of sound, जिसके लिए हम लेवल मेजर कर रहे हैं. ओके, आई नोट एंड पी नोट आर रेफरेंस. दे आर या तो क्वेश्चन में गिवन होते हैं, अदरवाइज इनकी एक फिक्स यूनिट है. आई नोट इक्वल टू 10⁻⁻12 एंड पी नोट इज 2 into 10⁻⁻5. या ओके, you can do this by derivation. 10 log 10, as we know I is directly proportional to p square, so p square upon p reference का square decibel. As we know power in the log will come outside. 10 log 10 p upon p reference decibel. That is the formula of sound pressure level, and this is the formula of sound intensity level. Okay, this is only from the sound, that is from the sound. Now we will talk about the numericals of heat and ventilation. Heat and ventilation numericals. In heat, if we talk about heating, there is two factors, U and R. U is the heat transmittance and R is heat resistance. Unit of heat transmittance is watt per meter square degree Celsius, and this is the U is equal to, U is inversely proportional to R, means heat transmittance is inversely proportional to heat resistance, so its unit will be m square degree Celsius upon watt, or m square degree Kelvin upon watt. Okay. Now from the heat transmittance, one term comes in heat transmittivity, that is W m Celsius, and same as resistivity, that is m degrees Celsius by W. These both are independent of their length. These are dependent of length. Okay. Now in solving these heat equations, we can add only R values. We can add and subtract only R values, means heat resistance value. If in question we are given with U values, we have to first convert U values into R values, then we will going to solve these questions. Okay. For example, if there is a wall and it has a covering, if its value is given R and length Z, and this is given, means let's assume heat transmittivity means rho, and this is given heat transmittance U. U value is given for this R, and R value is given for this wall, and rho value is given for this covering. Okay, so first we will find out the U value of this wall. Thickness will be given X and Y. So from the formula we can see that we will have to divide the rho from the meter, that is length. This value will be U, u of 1, and we have given r of 2, say 1 2 3, and u value of 3 is given u. But as we have known that we can add and subtract only r values, so will have to convert all these values into r values. This is already converted, so u1 will be r1 will be 1 upon u1, and r3 will be 1 upon u3, that is 1 upon u. It's very simple. Now we can add all these values, r1 plus r2 plus r3, that is 1 upon u1 plus r plus 1 upon u, the total r. Now if they ask for total u value, after finding the rt, we can find out the total u values will be 1 upon rt. This will be the total value. Okay. Now the heat we can find out the heat resistance. Heat resistivity means in question if we are given with heat resistance, and we know the formula ampere degrees Celsius watt, its unit, and we have to find out the resistivity, that is m degrees Celsius watt resistivity. So we have to just divide it by length or the thickness. The thickness we have given is this Z, so we can just divide the value by Z, and we can find out the resistivity. Similarly in the transmittivity. Okay, now coming to the question of ventilation. If we have to find out heat, there are simple formulas जो डायरेक्टली अप्लाई होंगे, लाइक हीट ट्रांसफर वोट का था इज डेल्टा टी इंटू यू वैल्यू इंटू area, okay. And delta T we have known, U value, delta T is the difference in temperature, means outdoor minus indoor. This is the delta T, and U value we have learned from last. U value is heat transmittance. Okay. Now for the ventilation, simple formula and direct formula is N into volume per rate, or volume rate into specific heat into delta T. N will be number of air changes, volume rate means room of volume per second, specific heat, either it is given in question or its constant value will be 1300, and delta T is same temperature difference. Specific heat will gonna depend on the question, and its value is usually given in the question. This is from the ventilation and heat. Okay. Okay. We will take a numerical of ventilation, that is 2016 gate, question number 42. In this numerical we have given the opening area of window 0.35 square meter, and air velocity is equal to 0.5 meter per second. Delta T temperature difference 10 degrees Celsius. Specific heat is equal to 1250 joules meter cube degree Celsius. Specific heat joules meter cube degree Celsius. Okay, we have to find out how much heat exchange. Heat exchange. Okay, for the heat exchange the formula is simple. Volume rate open area into velocity will be volume, that is 0.35 into 0.5 volume into delta T into specific heat will be your total heat exchange. Okay, okay, and assuming 1 ton of the further question is now coming to the topic of construction management. Construction management. In this topic, only numericals comes from CPM and PERT. Their difference we should know their difference and their definition, etc. And main numericals, I will write down just formulas because we all are familiar with CPM and PERT chart. For example, we have given activity and duration and their primitives. We can make this diagram easily, whichever you want to choose, arrow on the nodes or nodes on the circle, activity on the circle or activity on the arrows. We just know how to find out the critical path method. This is CPM, critical path method. Duration is like anything. After find out CPM, the main question comes is finding out the CPM, finding out the slack time, early finish, early start, and late finish, late start. दिस इज़ द नॉर्मली जो हमें कॉलेज में पढ़ाया जाता है. अब नाउ द गेट में एक्स्ट्रा क्या आता है. एक्स्ट्रा गेट में 4 टर्म्स आती हैं, 4 न्यू फॉर्मूलाज. दैट इज़ सिंपल सा है, मैं तरीका बता देता हूँ याद करने का. टोटल सेफ्टी फ्री इंडिपेंडेंट, टोटल फ्लोट, ये सारे फ्लोट टाइमिंग्स होती हैं. इनको याद करने का तरीका है लेट फिनिश, लेट फिनिश, अर्ली फिनिश, अर्ली फिनिश, माइनस 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 माइनस, ड्यूरेशन 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 प्लस. नाउ सिंपल अर्ली स्टार्ट, late start, early start, late start. These are the simple formulas which we have to learn for the gate purposes. Okay, now if in the question is asked total float timing for S, so for the S activity, assume S is here, duration will be given, and his late finish and late early start we have to just solve down it and we can get the easily answer. This is from the CPM. And now the PERT is probabilistic, as we all know. Just depend on the three times: optimistic, pessimistic, and most likely. Optimistic, we know when the conditions are good; pessimistic, when conditions are not good; most likely, when conditions are in betweens. Now the main question comes from expected time. Finding the expected time. That is the simple formula: optimistic time plus 4Tm plus pessimistic time upon 6. This is a simple formula for expected time. And variance and standard deviation, P minus O upon 6 का whole square, and standard deviation we all know under root of variance. Now one more question from which can we come is the probability for the time. Answer for this, the formula is expected time minus probability time upon standard deviation. The probability time in the question, it may be asked that expected time is given this, and u value probability time. Find out the probability for the time. Means in question it may be given that find out the expected time. Then they said for example 40 years, find out what is the probability to be completed in 40 years. So we will use this formula, z minus u upon standard deviation. This is the formula for probability for time. Now after this Gantt chart and bar chart, we all are familiar with all these charts. This is activity, this is time taken by Gantt chart, every activity, and it's simple. So that is all from the construction management. Now coming to the scoring part of the GATE is structure. स्ट्रक्चर से बेसिकली 3-4 क्वेश्चन आते हैं एंड सारे एकदम परफेक्ट निकल जाते हैं. आई विल जस्ट गो थ्रू द प्रीवियस पार्ट. एज वी ऑल नो 3 टाइप के रिएक्शन फोर्सेस होते हैं. That is, first one will be pin, roller and fix. We all know कि पिन में 2 टाइप्स की रिएक्शन लगती है, Fx in the x direction and Fy in the y direction. रोलर में जस्ट Fy लगती है एंड फिक्स में लगती है 3. फिक्स में थर्ड वन भी मोमेंट Fy and Fx. Okay. Now just question simply comes, simple supported time, simple supported beam is given, support, and P is the load, and 2 simply supported reactions are A and are B. Now firstly we will make the free body diagram. Actually it is the free body diagram. We will make free body diagram in other question. Now as we all know, in equilibrium, as this beam will be in equilibrium, so all forces in every direction will be 0. Means summation of Fy, summation of Fx, and moment will be 0. So first in this case Fx is already 0. So in Fy case, summation of Fy will be 0. there are three forces in the y direction, that is Ra plus Rb minus P is equal to 0. Take your sign convention. We are going to take plus, plus and plus. Moment in the clockwise direction we will take, anti-clockwise direction we will take positive. So from the first equation we will get Ra plus Rb is equal to P plus Rb equal to P. Now for the moment, you can find out at any point. Let's take moment at A is equal to 0. Okay, now for the moment at A, at that point, P into, let's take this is the resistance L by 2, P into L by 2, this is in direction, so we will take negative plus Rb. Now the another force is Rb. Rb is in direction, this direction, that is our positive direction. Rb into respective length L into L equal to 0. Ra into 0, because distance from this point of Ra is 0, so Ra is equal to 0. Now Rb L is equal to P L by 2, so we can get L say L and Rb is equal to P. So Rb we get P, and from that equation we know that Rb plus R is equal to P, sorry, P by 2. So we will come with R is equal to P by 2. We will get the both reactions. Okay, now the question comes is find out the bending moment at point P. Let's suppose they have asked for point P. Now to find out the bending moment at P, we'll have to make a new diagram. We will just cut down the slab, sorry, beam, and make another free body diagram, that is A पे Ra force and L by 2 and F, sorry, P. Just either you can take to the left side or you can take the right side of the beam to find out the bending moment at P. Okay, for finding out bending moment at P. Now bending moment at P will be, take the all forces, only just Ra into L by 2 and Ra we know that P L by 2, P L by 2. Okay, you can make the shear diagram and bending moment diagram. A, B, P. From the shear body diagram, we find out that at point Ra, we have taking positive direction, Ra ऊपर लग रहा है, and the value of Ra is P by 2. Value of Ra, let's suppose P by 2. Now here is, now यहाँ पे कोई भी force नहीं है, so till P it will be same, but at P in the negative direction we have P force, P shear force, so the P by 2 minus P by 2. Okay, now till B we have no other force, so straight line, but at B we have again force in the upward direction, that is P by 2, so we will gain negative P by 2 shear force. This is the shear force diagram. Now for the bending moment diagram, you could find out the values by M at A, M at B, M at P, M at A will be 0, M at B will be 0, and M at P we have find out PL by 2. Bending moment at P is PL by 2. So it will be like this. Okay. I'll tell you simple things. If the shear force diagram is straight, then bending moment diagram will be this. If shear force diagram is in angle, means for UDL, shear force diagram is UDL, then bending moment diagram will be like this. In this case, it will be like this bending moment diagram. Okay. Okay. Let's take another example. First, we will solve out all the cases. Okay. If there is a UDL, W, A, B simply supported beam, L is the distance, L by 2, simply support is given. Now at summation of fx 0, fy will be 0, so Ra plus Rb is equal to 0, and Ra plus Rb is equal to 0 not, it will be omega into length, that is omega L, which will act as a point load at the center. UDL will into with its length act as a point load at its center at L by 2. Now taking again for finding the values Ra and Rb, taking the moment at A will be 0. You can take moment at B, you can take moment at C, at any place for finding the values of Ra and Rb. Now taking moment at MA 8.0, so we will make a free body diagram at A0 omega L, that is B, RB, L by 2, and that is L. Same here, MA will be omega L into L by 2. We are taking this side positive, okay, so it will be negative and it will be positive. RB into L equal to 0, RBL equal to omega L upon 2, omega L upon 2, and RA will be again omega L upon 2. So in general case, if point load is given at the center, it will be equally divided into two simple supported beam or simple supported reaction Ra and Rb. If a point load or a simple load is given, UDL, we can convert UDL into point load, it will be equally divided into Ra and Rb, that is omega L upon 2, omega L upon 2. Now the finding bending moment at the center, so we will make another bending moment at center. We will make another free body diagram till point, name it as a C, till point C, that is this Ra L by 2, that is omega, and its UDL will be omega L by 2. will act at its center. This is full L by 2. Now the finding point bending moment at C, we will find out. At C the reactions will be RA, we will take this side again positive, RA into L by 2 negative omega L by 2 omega L upon 2 into the distance will be L by 4. L by 4. Okay. Moment at C. Now the value of RA is equal to omega L upon 2 minus L square upon 8 omega L square upon 4. This will be omega L square upon 8. So case 1, if beam is UDL, point load, and reactions RA, RB, and suppose UDL is omega, then RA equal to RB is equal to omega L upon 2, means half of these all loads, and bending moment at center will be omega L square by 8, and this is the maximum bending moment. Case 1, you can note it down. Case 1.